Welcome to this online review, and I'm just going to give you the important equations and explain the terms as quickly as I can. Number one, kinematic equations. Vi is the initial velocity. So, for example, if it says it starts from rest, then the velocity is 0. Vf is the final velocity. A is the acceleration, and t is the time that has passed. Now those are four, and the fifth one is x. And x is the displacement, which could also be distance if it's in a straight line. So in this equation, displacement and distance would be the same. So once again, you have initial velocity, vi, final velocity, vf, a is the acceleration, t is the time elapsed, x is the displacement or distance in this chapter. And you have these four equations. Number two, I just wanted it to come out slowly. Motion in two dimensions. In this case, what you have is a velocity or a force, in this case particularly velocity at an angle. You have the vertical and the horizontal, and this velocity can be resolved into two components. If the angle is theta and the velocity is vi, then the horizontal component is going to be vi cos theta and the vertical is vi sin theta. That is the path taken by the projectile, and there are three quantities that we could define and calculate. One is the time taken by the projectile to go from the point of projection along this path to the final point. The time taken. To find the time taken, of course, we use the initial velocity as the vertical velocity. So we'll call it TAB. Now, to find the time taken, always use VI sin theta. Same thing to find the maximum height. Remember, this is the maximum height. To find the maximum height, again use VI sin theta. But to find the horizontal distance AB, XAB, because it's along the x-axis, use VI cos theta. And remember that since it's a constant, you're going to multiply that with the time to get the horizontal. Okay, when you find maximum height, remember the vertical velocity here is 0. And also when you find time, understand that the total vertical displacement is 0. That's why I've written YAB is equal to 0 and VF is 0. So that is the review about motion in two dimensions. So to find the time of a flight and the height, use VI sin theta. But if you're asked to find the horizontal displacement, then use VI cos theta. Number three, Newton's laws of motion. There are three laws, but there's only one important equation that comes out. That is, the net force is equal to mass times acceleration. Now to illustrate that, here is a setup, and here you have two objects of masses m1 and m2 attached together by a string passing over a frictionless pulley, and you have to treat this as a free body diagram. So when you look at the forces acting on mass m1, there are two forces. m1g is its weight acting down, Ft is the tension in the string. So when you set up an equation and assuming that m1 is greater than m2, so that means this will be going down, right? It will be going down. Therefore, which force is greater? Is it m1g or Ft? Because it's going down, m1g would be greater. So when you take the net force, you're going to take m1g minus Ft is equal to its mass times acceleration. But when you come to the second mass, the tension is one of the forces and the other is its weight acting down. Now what direction is this mass moving in? Upwards, correct. Therefore, Ft must be greater than m2g. So when you set up the equation, it's going to be Ft minus m2g is equal to mass times acceleration. And then to solve, add these two equations. The plus Ft and the minus Ft will cancel out. You get m1 minus m2 times g is m1 plus m2 times a. Rearrange to get a as the subject. And once you get a, you can substitute into this equation to get Ft. Just by taking m2g to the other side, it will become plus m2g. Now you have the value of a from here, so just substitute that into this and calculate the tension. I'm going to give you another example of connected systems. In this case, you have one moving horizontally, the other moving vertically. The difference here is going to be when you take this mass, it's just like before. m1g minus Ft is equal to m1a. m1g minus Ft is m1a. Okay, but when you come to the second object, although its weight is acting vertically down, that has no influence on its horizontal motion. Therefore, the only force acting on this is Ft, correct? Therefore, Ft is m2a. Now add the two equations. The negative and the positive Ft's will cancel. You will get this. Rearrange to make a the subject. And then once you get a, substitute into this equation to calculate the tension. Yeah, m2 times a, so you will get m2 m1g by m1 plus mt. Alright, next we have conservation of momentum. Conservation of, okay, I think I put that in another slide. This is conservation of energy. Now, according to conservation of energy, the total energy is constant. We know there are two types of energy. One is potential energy, which is mgh. Gravitational potential energy is mgh. Kinetic energy is 1/2 mv squared. If you take the sum of the two, you get total energy. And total energy is conserved. That means total energy is constant throughout the motion. So, let me give you an example. Let's say you're throwing something, throwing an object, and in its path there are 3 points, and at these 3 points its total energies are E1, E2 and E3 according to the principle of conservation of energy. E1 is equal to E2 is equal to E3. That means if you add, okay, let's take the heights at 2 points to be H1 and H2. So the potential energy mgh1 plus 1/2 mv1 squared should be equal to mgh2 plus 1/2 mv2 squared. I hope that's very clear. So if you take the sum of the potential and the kinetic energy at any 2 points in the path, the total energy must be a constant. That brings us to an impulse. An impulsive force is a large force acting on an object for a short time. Examples would be hitting a baseball with a baseball bat. Okay? And impulse is measured by the product of force and time, or mass multiplied by the change in velocity. So there are two formulas for impulse. You can put the two formulas together. Let me give you an example here. This is a mass, m. Its initial velocity is vi, And if you apply a force F on it, its velocity increases, changes to Vf. Therefore, and if the force was acting for delta t seconds, we can write force is m Vf minus Vi by delta t. Let the mass be 2 kilograms. Vi is 5 meter per second. Vf is 15 meter per second. And if the time was considered to be a 0.1 second, then surely the force applied is 200 Newton. Isn't that simple to understand? So that's about an impulsive force. Next, the conservation of momentum. According to the conservation of momentum, the total momentum is conserved if there is no external force acting on the system. Here is an example. Two objects, the masses ma and mb. Okay. Before they collide with each other, their velocities are va and vb. After, the velocities become va prime and vb prime. That's where the collision took place. And so, according to the conservation of momentum, MAVA plus MBVB is equal to MAVA prime plus MBVB prime. My telephone has to ring, sorry. Okay. Now, if the second object was at rest, then its momentum is zero, of course, because the velocity is zero. Just keep that in mind. Okay, so that's the conservation of momentum. The total momentum is conserved if there is no external force acting on the system. That brings us to torque. Torque is actually defined as tau is Rf sine theta. Rf sine theta. Torque is Rf sine theta. R is the distance. Okay. The force is acting along this line. The angle between the line of action of the force and the distance is theta. And we're calculating the torque here. Okay. So that's R, that's F, and you can see theta. Example, if F is 25 newtons, theta is 30 degrees, and R is 10 meters, then 10 times 25 times sine 30. That's going to give you 125 meter Newton. Okay, that's torque. Carnot's engine. Yeah, this heat engine, there are two formulas for efficiency of Carnot's engine. One is in terms of QH and QL, the other in terms of TH and TL. Let me tell you what these are. QH is the heat absorbed from the hot source. QL is the heat rejected to the low temperature. So the H stands for high and L stands for low. Now, TH and TL are their temperatures. Okay, so Q shows heat and T shows the temperature. So what's QH? QH is the heat absorbed. That's going to be in joules. TH is the temperature of the object from where the heat is absorbed. QL is similarly the heat rejected, means given out, to the low temperature object whose temperature is TL. And work is given by QH minus QL. That's understood. For example, if 1000 joules is absorbed and 700 joules is rejected, that means 300 joules was converted into work. Isn't that easy to understand? Okay. And if the hot source had a temperature of 500 Kelvin, can we find the temperature of the cold source? Yes. You can just take it as a ratio and do it directly, or do it the long way. So you understand. work is 300 joules. The efficiency is given by work over QH, which is going to be 300 joules divided by 1000 joules, which gives 0.3, but as a percentage, that's going to be 30%. But efficiency can also be calculated using the formula TH minus TL over TL. Alright, since we know that the efficiency is 0.3, and do not use the percentage there. And when you bring this TH over to the other side, you multiply, correct? So you get 150 is equal to 500 minus TL. Switch sides and you get TL is 350 Kelvin. Now, you could have just done it this way. QH over QL is TH over TL. You can see that 500 is half of 1000. Therefore, you have to get a number which is half of 700. That is 350. But then why did I make you go through the process? Just to show you what work is and how to calculate the efficiency in two different ways. I hope that's clear now. Conductivity. In summer, the temperature outside is so high, and therefore heat from the outside flows into the house, right, through the walls. So heat always flows from a high temperature point to a low temperature point. As an example, if that is a wall and the temperatures are T1 and T2, and if T1 is greater than T2, then heat flows in the direction shown. If Q is the quantity of heat flowing in T seconds, then the formula is Q by T is Ka T1 minus T2 by D. Just have to tell you what these terms are. Q is the quantity of heat flowing, T is the time in which it flows, D is the thickness of the wall, as you can see, A is the area of cross section of the wall, this is the area of the shaded surface, T1 and T2 are the temperatures, and K is the constant called the conductivity, thermal conductivity, which will be given to you. Now, do also remember that if it's a sphere, the surface area of a sphere is 4 pi r squared. Need to remember that, 4 pi r squared. So, in place of A, you will use 4 pi r squared if it's a sphere. Bernoullis Principle, how can we ever forget about the principle that helps us travel in an airplane? Okay, so let's look at that, Bernoullis Principle. That's the wing of the airplane. The velocity of the air at the bottom is V1 and at the top is V2. And the pressures at the bottom, P1, at the top, P2. Do you notice that since velocity 2 is higher than velocity 1, do you notice that the pressure is smaller? Well, you should. That is Bernoullis Principle. Where the velocity is higher, the pressure is smaller. But how do you calculate that? Use the principle. Pressure energy plus kinetic energy on both sides must be equal. So that's the equation. And we're not considering potential energy because it's horizontal, okay? So P1, P2 are the pressures, V1, V2 are the velocities. Rho is the density. In this case, it is the density of air. P1 is greater than P2, that's why there is a lift upwards and the airplane is able to stay in the air. Alright, circular motion. Circular motion, the force that acts on an object moving in a circle, is called the centripetal force. It's given by mv squared by r. So when your car takes a curve, it's going around a part of a circle and there is the centripetal force acting on it. M is the mass, V is the velocity, and R is the radius. So if it is a sharp curve, then the radius is small, so the centripetal force would be bigger. Also want to show you how to change kilometer per hour into meter per second. What do? Multiply by 5, divide by 18. Multiply by 5, divide by 18. So you get 15 meter per second if it is 54 kilometer per hour. Okay, with this, I think I've given you the most important topics that you really need to study before the exam tomorrow. Thank you.